let's talk about stateful sets in Kubernetes. So stateful sets are specialized resources used for managing stateful applications. Unlike deployments, which are used for stateless applications where each pod is identical, stateful sets are designed to manage applications where each instance or pod needs to maintain a persistent identity, stable network identity, and stable storage. This makes stateful sets particularly useful for databases and other applications that need to retain data across restarts or scale events. In terms of the stateful set architecture, the pods have stable identities. So each pod in a stateful set has a unique stable identifier that is maintained across scaling, rescheduling, and restarts. So these identifiers are based on an ordinal index. For example, pod-0, pod-1, and pod-2. So these are the stable identities for a pod. If a pod in a stateful set is deleted, Kubernetes ensures that a new pod with the same identity is created to replace it. The second concept is ordered, predictable deployment and scaling. So pods in a stateful set are created in a sequential order, which means that the Kubernetes framework creates and starts the first pod, pod 0, and once it's fully running, the next pod, pod 1, is created. And similarly, when scaling down, pods are deleted in reverse order from highest numbered pod down to the lowest. So one critical aspect is stable network identity. So each pod in a stateful set gets a stable DNS hostname. And this hostname is based on the stateful set name and the pod's ordinal index. And this format is typically stateful set name, and then a dash, followed by the ordinal index. For example, let's say a stateful set is called web. The pods would be assigned names like web-0, web-1, web-2, and so on. And this provides a stable network identity, which enables applications that depend on the pod identity, such as databases, to maintain connections and configurations across restarts and scaling. Next, we have stable persistent storage. So stateful sets work closely with persistent volumes, or PVs, to ensure that each pod gets its own stable storage, typically through persistent volume claims, or PVCs. And each pod in a stateful set is associated with its own persistent storage. And this storage is retained across pod restarts or migrations to different nodes. And even if a pod is rescheduled to another node, Kubernetes will reattach the same volume, ensuring that the pod's state is always preserved. Next, we have pod management policies. The first policy is parallel. So what does this mean? Pods can be started or stopped in parallel, which can be useful for improving speed in certain scenarios. And the second policy is called ordered ready. So pods are created and destroyed in a strict order, which is the default behavior. And this ensures that services that require strict ordering, such as a distributed database, can function as expected. And another concept involved in stateful sets is known as headless services. So stateful sets are typically associated with headless services, which allows each pod to be directly addressed using its stable network identity. And this differs from regular services, which distribute traffic to any pod using a common IP. And to better explain this, regular services, so in cases with regular services, all pods share a single address and traffic goes to whichever pod is free. In the case of a headless service, each pod has its own address, so you can directly contact a specific pod. So when should we use stateful sets? Stateful sets are ideal for applications that require the following features, right? Stable, unique identities for each pod, ordered deployment and termination, as well as stable, persistent storage for each pod, even if the pod is restarted or rescheduled to a different node. So now let's take a look at an example of a stateful set. This is a YAML configuration for a stateful set, and we can see that we have the service name set to my app under spec.servicename. And this stateful set is associated with this headless service called myApp. And this allows each pod to be addressable by a stable DNS name. Also, the replicas is set to 3, which means that 3 pods will be created: myapp-0, myapp-1, and myapp-2. And if you look at volume claim templates, this is ensuring that each pod gets its own persistent volume. In this case, the metadata.name is setting this persistent volume to myapp-volume. That is independent and stable across pod rescheduling.